If an integral curve of the differential equation y minus x dy over dx is equal to 1 passes through this 0 0 means origin and alpha comma 1, then alpha is equal to, means we have to find the value of alpha which is used in this coordinate xy. So to find the value of alpha, first we need to solve differential equation as y minus x dy over dx is equal to 1, and integral curve means solution curve, means a function of y, because y is a dependent variable, so its integral curve will be yx, that will be the solution curve. So the beauty of this question, or the purpose of ask this question, is very similar, sorry, very easy, but sometimes it may confuse you, because if you write dy over dx equal to 1 upon y minus x, then you cannot separate variables, so variable separable method you cannot apply. Also this types of differential equation you cannot see dy over dx plus px, and this is independent variable y equal to qx. Also the structure of this differential equation doesn't appear like that, but if you take dx over dy, then you can write y minus x, and in this way you can write this differential equation dx over dy plus x equal to y. Now this is structure of this differential equation dy over dy, dx over dy plus p, or you can write py, and function, this is now dependent variable, is equal to qy. So you can think that this is py, and value of py is nothing but 1. So first we have to find the integrating factor of this one. So integrating factor of this one will be e raised to the power 1 dy, and value of this one will be e raised to the power y. Now we have to find the solution, because dependent variable is x, so x into if means integrating factor as e raised to the power y, and we have to take integration of q, and if, this is e raised to the power y dy. This will be the solution, and you can add constant of integration also. So x e raised to the power y, and q is y e raised to the power y dy, and now we have to integrate this one, so x into e raised to the power y, and we have to apply integration by parts. So first one will be same, and integration of second one will be this, minus derivative of first one will be 1, and integration of this is again e raised to the power y plus c. We solve this by integration by parts. Now as given condition is value, this solution curve is passes through this one, means we have to put x as 0 and y is also 0. So 0 into e raised to the power 0, this is 0 minus e raised to the power 0 plus c. So this is 0, and value of c is 1. Value of c is 1. Now put this value of c in this solution. So x e raised to the power y equal to y e raised to the power y minus e raised to the power y plus 1. This is the integral or solution. Now another condition is alpha comma 1 is also passes, means this integral curve passes this point also. So put x as alpha, and value of y is 1. So alpha e raised to the power 1 is equal to 1 e raised to the power alpha minus e raised to the power 1 plus 1. So e alpha is equal to e alpha e raised to the power alpha minus e plus 1, and we have to find value of alpha. We have to find the value of alpha. So alpha is appearing here and here, so you can write, so value of y was 1, so this is 1 and this is 1, so this was my mistake. Now this is e minus e plus 1, so this one cancel out, so e alpha is equal to 1, so value of alpha is equal to 1 upon e, or e inverse, means which one option is correct answer? Option C is my correct answer.